Lockheed Martin can build the airframe, Raytheon can build the radar, but no defense contractor on Earth can build the pulse of the pilot inside the cockpit. That is the one variable that physics cannot quantify. When a pilot catapults into a pitch-black night over the Pacific, that is the pinnacle of the human spirit. But courage has a predator, and that predator is undefeated. It is the second law of thermodynamics. When the fuel gauge hits bingo and the nearest deck is 400 miles of dark water away, willpower does not generate lift. Determination does not generate thrust. Only JP5 jet fuel saves your life. For the last 30 years, we have made a strategic error. We have relied on the bravery of our pilots to compensate for a deficit in our physics. We demanded they fly harder, push further, and risk more. But the era of compensating with guts is over because the map has changed. Look at the Pacific Theater. Don't look at it like a politician. Look at it like an engineer. This is a geometry problem. We possess the Gerald R. Ford class carriers, $13 billion of American steel. We operate the F-35C, the most advanced stealth fighter in history. But in a peer-level conflict, we are trapped in a geometric prison. The enemy's anti-ship ballistic missiles, the DF-21s and DF-26s, create a kill zone that extends out more than 1,000 nautical miles. Our primary strike asset, the F-35C, has a combat radius of roughly 600 nautical miles. That is a 400-mile gap of dead water to land a punch. Our heavyweight boxer, the Carrier, has to step inside the reach of an opponent with longer arms. That isn't bravery, that is a suicide pact. So, what is the solution? Do we accept the math and retreat? Do we ask pilots to fly one-way missions? No, we change the geometry. Enter the MQ-25 Stingray. It has no cockpit, it has no ego, it has no desire for a medal. It was not built to be a Top Gun. It was built for one specific industrial purpose: to turn a short arm into a long arm. It is the cold, calculated engineering answer to the survival of the fleet. Today, we decode the machine that breaks the geometric cage holding back American power. If you are here for the physics, not the speeches, verify your subscription. Let's begin. To solve this, you have to look at the ground beneath the tires. On land. Logistics is a science of infinite space on a carrier deck. Logistics is a violent art form, constrained by 4.5 acres of moving steel. The United States Air Force operates in luxury. They fly from 10,000-foot concrete runways. They have space. This luxury allows them to operate massive flying gas stations, like the KC-135 Stratotanker and the KC-46 Pegasus. These aircraft use a flying boom. It is fast, it is stable, it pumps fuel at high pressure, it is the gold standard. But the Navy does not have concrete, we have steel. And on a carrier deck, space is the most expensive real estate on planet Earth. You cannot park a Boeing 767 on the deck of the USS George H.W. Bush. So, the Navy has to improvise. We use the probe and drogue system. It is flexible, it is compact, and it is difficult. It is like threading a needle while riding a galloping horse. But here is the real crisis. Because we cannot land giant tankers on a ship, we have been forced into a band-aid solution for the last 20 years. We use the fighters themselves. We call it buddy tanking. We take an FA-18 Super Hornet, a supersonic fighter jet designed to pull 9 Gs and kill bad guys, and we hang 5 massive fuel tanks on it. We take a supersonic Apex Predator and degrade it into a subsonic pack mule. This is thermodynamic waste. Right now, 20 to 30% of all Super Hornet sorties are flown just to pass gas to other planes. Think about the economics of that. We are burning thousands of dollars of fuel just to carry fuel. The parasitic drag from those tanks is enormous. The engine efficiency at low speed is terrible, but the money isn't the problem. The problem is the metal. Every time a Hornet launches with that heavy 5-wet configuration, the catapult shot sends a shockwave through the airframe. Every time it slams back onto the deck, the arresting gear tears at the landing struts. We are inducing metal fatigue at an accelerated rate. We are burning through the fatigue life of our primary fighters before they ever fire a shot in anger. This is a vampire economy. We are cannibalizing the fleet from the inside out to sustain operations. The MQ-25 was born from the ashes of the U-class program, to stop this bleeding. Its mission is not just to extend the range, its mission is to buy back the soul of the air wing. It exists to take the burden off the Super Hornet, so the fighters can go back to doing what they were built for: kinetics, not logistics. But to do that, Boeing had to solve an engineering paradox that has plagued aviation for decades. How do you build a tanker that is efficient enough to loiter for hours, but stealthy enough to survive the front lines? The answer lies in the engine, and it's not what you think. The fleet was cannibalizing itself. We were taking our sharpest swords, our elite pilots, and using them as dull hammers. We were burning through the fatigue life of our fighters like a starving man eating his own muscle just to survive. To stop this waste, the Navy had to make a cold-blooded decision. Not to replace the pilot, but to unleash them. We needed a machine to take the burden, so the human could focus on the battle. A machine that doesn't mind the boredom of a 6-hour orbit. A machine that obeys only one god: logistics. They built the MQ-25 Stingray. It is the industrial answer to a human problem. And to understand why this silent ghost is terrifying to our enemies, we have to strip away the marketing hype and decode the 4 engineering paradoxes that give it life. First, let's talk about the heart, the engine. The internet loves to make jokes about Rolls-Royce making luxury cars. Stop it. Rolls-Royce is a titan of aerospace propulsion. The MQ-25 is powered by the Rolls-Royce AE3007N turbofan. Why did the Navy choose an engine used on regional jets? Why not build a new, cutting-edge military engine? Because of risk management. Developing a new engine takes 10 years and $2 billion. The Navy didn't have time. They went to the commercial shelf. This engine is a high bypass masterpiece. Unlike a fighter jet engine, which sucks fuel to create raw supersonic thrust, a high bypass engine is designed to move massive volumes of air at subsonic speeds. It is thermodynamically optimized for one thing: loitering. A Super Hornet burns fuel just to stay airborne. The MQ-25 sips it. It can circle the carrier for hours, acting as an endless reservoir of JP5. But the real genius here is logistics commonality. This is the exact same engine core used on the MQ-4C Triton and the Global Hawk. In military engineering, commonality is king. It means we use the same mechanics, the same spare parts, and the same supply chain. We are not reinventing the wheel. We are standardizing the kill chain. Now, let's look at the skin, specifically the intake. Look at the back of the aircraft. You will see a flush inlet. It sits flat against the fuselage. This is not an aesthetic choice. It is a survival choice. A traditional engine intake is a giant radar reflector. It allows radar waves to travel down the throat of the engine and bounce off the compressor blades. It lights you up like a Christmas tree. By burying the inlet flush on the top of the fuselage, Boeing hides the engine blades from ground-based radar. But there is a catch. From a fluid dynamics perspective, flush inlets are a nightmare. The air flowing over the fuselage creates a boundary layer: turbulent, dirty air. Engines hate turbulent air. It causes compressor stalls. Boeing had to engineer a way to suck in clean air while keeping the profile flat. They solved a fluid dynamics problem that has baffled engineers for decades. And then, there is the exhaust. It features an inset exhaust nozzle. It buries the heat source deep inside the tail structure. This mixes the hot exhaust with cool ambient air before it ever leaves the aircraft. Why? To defeat infrared search and track systems. Critics point to the non-stealthy refueling pod under the wing and say the stealth is broken. They are missing the point. Stealth is a spectrum. The MQ-25 is not a B-2 Spirit. It is not designed to penetrate deep into downtown Tehran. It is designed to be low observable. It is stealthy enough to survive on the edge of the battle space, where a KC-135 would be destroyed instantly. But it is cheap enough to be produced in mass numbers. It is a calculated trade-off between invisibility and utility. Most people think this is just a flying gas tank. Look closer. Under the nose, there is a turret. That is the Raytheon ANDAS-4 multi-spectral targeting system. This is the same electro-optical sensor used on the MQ-9 Reaper. Why put a high-grade spy camera on a tanker? Because in the Navy, every asset must be a sensor. When the MQ-25 is not pumping gas, it is not sleeping, it is watching. It provides intelligence, surveillance, and reconnaissance for the fleet. It can track enemy surface ships, spot periscopes, or monitor choke points. It turns a dumb logistics truck into a smart node in the network. It pays for its own existence by being the eyes of the fleet, when the E-2D Hawkeye is busy elsewhere. But the most revolutionary piece of engineering on this machine isn't in the sky. It is on the wrist of a 20-year-old sailor. Welcome to the Carrier flight deck. It is 140 decibels of chaos. It is the most dangerous 4.5 acres on the planet. For decades, we moved aircraft using hand signals. A yellow shirt waves his hands, and the pilot interprets the command. But hand signals are analog. They are subjective, and in the fog of war, they are a single point of failure. The MQ-25 deletes the pilot from the cockpit, but it keeps the human in the loop. We call it the Deck Control Device, or DCD. It is a display strapped to the right arm and a joystick on the belt. The operator, the deck handling operator, walks right next to the drone. This is battlefield ergonomics. This is not about gaming culture, this is about survival ergonomics. In a 140 decibel environment where voice comms are impossible, the deck control device provides deterministic, digital control. It removes the ambiguity of hand signals. The operator inputs a digital command: turn left, stop, move forward. The machine responds with absolute digital precision. This is not a video game. This is the elimination of human error. We have converted the movement of aircraft from a guessing game into a deterministic process. And once it launches, it uses JPALS, Joint Precision Approach and Landing System. It uses differential GPS to talk to the carrier. It knows exactly where the deck is, down to the centimeter. Even as the ship pitches and rolls in heavy seas, if the math doesn't line up, the robot waves itself off. No LSO shouting on the radio, just cold, hard calculus. In logistics, predictability is safety, and the MQ-25 is the most predictable machine on the deck. Now, let's stop looking at the blueprints and put this machine in the fight, because a machine is useless unless it fits into the kill chain. And this is where the MQ-25 stops being a science project and starts being a weapon. It does this by solving 4 tactical problems that have haunted the Navy for a generation. Let's look at the math. It is brutal. The MQ-25 carries 15,000 pounds of fuel at a range of 500 nautical miles. Now, critics on the internet will tell you that's not enough. An F-35C holds nearly 19,000 pounds of internal fuel. The drone can't even fill it up. They are failing basic arithmetic. The MQ-25 is not a gas station designed to fill an empty tank. It is a range extender. Here's the physics profile of a deep strike. To hit a target deep inside enemy territory, an F-35C has to launch heavy, full bombs, full missiles. The energy required to lift that weight off the deck and climb to altitude burns through 30% of its fuel in the first 20 minutes. By the time the fighter reaches the edge of the battle space, it's already thinking about going home. This is where the Stingray changes the calculus. The drone launches first. It loiters at the 500-mile mark. The F-35 meets it there. It takes on 5,000 or 6,000 pounds of fuel, a top-off. Now, the fighter is full again, but this time, it's starting its mission 500 miles closer to the target. We just mathematically shifted the launch point of the carrier without moving the ship. We turned a 400-mile combat radius into a 700-mile radius. We pushed the carrier back into the safety zone, and we pushed the fighter into the enemy's throat. But the F-35 is not the most important plane on the deck. The most important plane is the E-2D Hawkeye, the quarterback, the flying radar that sees everything. If the E-2D goes down, the fleet is blind. And in modern warfare, blindness is death. Here's the problem. The E-2D has massive turboprop blades. It is incredibly sensitive to wake turbulence. Trying to refuel a Hawkeye behind a Super Hornet is a nightmare of dirty air. The MQ-25, with its long, high aspect ratio wings, creates a cleaner wake. It is aerodynamically stable. This allows the E-2D to stay airborne for 8 or 9 hours instead of 4. It doubles the persistence of the radar. It means the eye of God never blinks. In a contested environment, radio waves are suicide. If a pilot gets on the radio to ask for gas, the enemy triangulates his position instantly. The MQ-25 operates on a silent network. It abandons the noisy, omnidirectional broadcasting of Legacy Link 16. Instead, it operates on low probability of intercept waveforms, or LPI. It doesn't shout, it whispers in directed energy. To avoid enemy detection, I need 4,000 pounds. The drone receives the request digitally. It calculates the intercept vector. It maneuvers. It drops the drogue. This is stealth logistics. We are not just hiding the airframe, we are hiding the conversation. Finally, let's look at the future. Look closely at the wings. You see those two hardpoints? Right now, they are carrying the aerial refueling store. But in engineering, a hardpoint is just a hardpoint. It is payload agnostic. Boeing and the Navy know exactly what this frame is capable of. Imagine a scenario where we don't need gas, we need kinetics. But the airframe is payload agnostic. In future Block II upgrades, the Navy has the potential to swap the fuel pod for long-range anti-ship missiles. The gas station evolves into a stealth sniper. That is the ultimate lethality roadmap. No pilot is put at risk. The gas station becomes a sniper. This is the ultimate potential of the Stingray. It is a modular truck. Today it carries JP-5. Tomorrow it carries high explosives. Let's look at the map one last time. At the start, I showed you a geometric prison, a trap designed to keep American power at arm's length. But look at it now. The trap is broken. We didn't invent a new physics engine. We hacked the geometry. We turned our biggest disadvantage, distance, into a manageable variable. If you appreciate this kind of unfiltered analysis, where we look at the blueprints, not the brochures, lock in your subscription right now. Because what I'm about to tell you next is not a prediction, it is a warning. This is not concept art. This is not a PowerPoint presentation for 2050. The future is already on the deck. Initial Operating Capability, or IOC, is set for 2026. By the early 2030s, the Stingray will be fully integrated into every carrier air wing in the fleet. Boeing is ramping up production right now. While critics are still debating the ethics of AI, the Navy is already deploying it. The transformation is not coming soon, it is here. For our adversaries, the window of opportunity just closed. But beyond the dates and the data, there is a deeper philosophy. In a world of hypersonics and lasers, the MQ-25 is quiet. It is subsonic. It is boring. It is the blue collar of the sky. But ask any Marine on the ground, ask any pilot in the air, who is the most important person in the fight? It's not the guy giving the speech, it's the guy who brings the ammo. It's the guy who brings the gas. The Stingray is the ultimate embodiment of that American ethos. No one left behind. It is a robot, yes, but it is programmed with a very human promise. We will wait for you. We will be there in the dark. We will get you home. That is not just logistics, that is loyalty. The enemy can steal our blueprints, they can copy our shapes, but they cannot copy this industrial momentum. They cannot manufacture the resolve to turn a cold machine into a lifeline. This is the reality of the unfair fight. This is Navy Decoded.